Good morning friends, welcome to my YouTube channel Free Education for Electrical Engineering. Today I am going to deliver a short lecture on a topic eddy current and hysteresis losses. So we will start our topic. Now what is eddy current and hysteresis losses? Eddy current losses and hysteresis losses are the two main losses produced in the DC machines. Now these losses, mainly there are three types of losses: iron losses, copper losses and mechanical losses, right? Hysteresis losses and eddy current loss are coming under the iron losses. So let us discuss what is the eddy current loss first. Eddy current loss is produced due to the relative motion between the core and the magnetic flux. Due to the Faraday's law of electromagnetic induction, whenever there is a relative motion in between conductor and the magnetic flux, a current is produced, and that current is known as the eddy current. The losses by this eddy current is known as the eddy current losses, right? Now let us discuss how this eddy current loss can be reduced. So mathematical expressions, we can write this WE means eddy current losses is equals to eddy current square into R of the core. What is I? That is the eddy current. And what is the R? This is the resistance of the core, right? Now as we know that this eddy current is directly proportional to the conductivity, so we can write this equation like this also. This eddy current is equals to conductivity square, and conductivity is 1 by resistivity, 1 by resistance. So instead of R, I have written 1 by conductance, 1 by conductivity, right? So my expressions now become this, right? So ultimately what happened? This is my expression number 1, this is expression number 2, and finally eddy current loss is proportional to conductivity. So now how to reduce the conductivity of the material? How to reduce the conductivity? Because we are aware that this eddy current loss is directly proportional to conductivity. So we have to reduce the eddy current, we have to reduce the conductivity. So mainly there are two methods by which we can reduce the conductivity of the material. Number one is by adding a silicon in the material. How to reduce the conductivity? So we are adding the silicon in the material, but at the same time we are adding in a very small quantity, 3 to 5%, right? And secondly, we are making the transformer's core, the solid core, into the thin strip of laminations. So we are converting solid core into the thin strip. Why we are doing this? Because R is equals to rho L by A. By making the thin strip of laminations, the area will be reduced. So if the area is reduced, resistance is increasing. If resistance is increasing, eddy current loss will be lower, right? So by increasing the high resistance, we are decreasing the conductivity. And if this conductivity is decreasing, eddy current loss is decreasing, right? So I will recall all the things. First, what we have discussed is eddy current loss due to the relative motion between conductor and magnetic flux. There is a current produced due to the relative motion in between the core and the magnetic flux. That is known as the eddy current. Due to this eddy current losses are produced. Mathematical expression for the eddy current loss is WE I square into R core. I is eddy current, R is the core, resistance of the core. We are knowing that this is proportional to conductivity, so I have replaced this conductivity. Here conductivity is inversely proportional to 1 upon R. So instead of R, I have written 1 by conductivity, and ultimately I would get eddy current equation is proportional to conductivity. And we have discussed the two methods how to reduce this conductivity, right? So please friends, like my videos, comment if any suggestions, giving in the comment box. I can also share the lectures in Gujarati as well as the Hindi. So please mention your comments. Thank you very much.